Good Tuesday morning. Welcome back to school after a little break. Sorry that I'm not here today, but I am at a golf tournament with the team. So I'll be back tomorrow, and we're going to do a little bit of factoring today. Again, I'd love to be there. I'll probably have to clean up a little bit of what we talk about today, but I want to start with where we finished. The last day of school that we had together, I don't know if you guys remember, we went over how to graph quadratic equations that are in standard form. If you guys recall, we used the equation x equals negative b divided by 2a. So hopefully you guys did these 4 problems. I want to take you a little bit through the first one step by step, and then the other 3 I'll just put the answers up so you can double check your work, and then we'll move on to what we're going to do today. So anyways, get this worksheet out and check your work. But if you notice, like we talked about the other day, whenever I have an equation like number 1 here that's in standard form, you do negative b. B is always that value that's in front of x, so negative b, so negative 8, divided by 2 times a, and a is that value that's in front of x squared, which in this case there's nothing there, so that's understood to be a 1. So we have negative 8, which is just 8, divided by 2 times 1, which is 2. So x equals 4. Now, I hope you guys noticed this, and I'm going to kind of take you through this like I said. But remember, we're trying to find that vertex, knowing that your axis of symmetry, which we just proved to be at x equals 4, knowing that the x value of my vertex is that value that is my axis of symmetry, 4. So what I showed you guys when we did this was to come over here into your calculator, and let me pull that thing up if I can. Let me see. Hide. Let me pull this out. I don't know why it's not wanting to. Okay, here it is. And I've already typed this equation in, cx squared minus 8x plus 17. You can grab it if you want, and you can kind of see what the graph is going to look like. But remember what I said was best, to go to your table, so second graph, and go put that 4, which is the axis of symmetry, go put it right in the middle. And then remember what we're supposed to check to see? We're supposed to check to see that these are symmetrical around it, which you see that 2, 2, 5, 5, 10, 10, perfectly symmetrical. So sure enough, we did the axis of symmetry correct. X does equal 4, and our vertex is at 4, 1. And then, of course, you can just take these other values and plug them in. So that's exactly what I've done. I've taken those exact values, just 2 on both sides of the vertex, and it's allowed me to get a really, really good view of what my vertex here is in this problem, and, of course, my parabola, which makes up this quadratic. So all of these answers, since it's opened up, that's a minimum. The axis of symmetry we found together, the vertex we found in our calculator, domain, look at this. It always goes, look, if I kept going, it's going to keep going left forever. I know we're talking about domain, so we're talking about x. So it's going to keep going left, it's going to keep going right forever. Maybe not very aggressively, it'll be very steep, so it's going more up, but it is also going left and right forever. But your range is limited. Look, y cannot come below this value. So the lowest value you can have on the y-axis is 1, but it can go up forever, so from 1 to positive infinity. So there's number 1. Hopefully you guys got that right. A lot of you finished this assignment before class even ended that last day we were together. Here's number 2. I'll leave it up for a second. In fact, since hopefully you've had time to look at number 1, I'll go ahead and put 2 and 3 up and let you look at those for just a moment. I'm not going to ask you to pause the video because I don't know exactly how long this video is going to be by the end. So I just want you to look at it, jot it down real quickly. Hopefully you already did these. See on number 2, your vertex is at -1, -4. I definitely recommend you type it in your calculator. You can see that it opens down, so it has a maximum, which changes the way your range is going to be. It'll go down forever, so it's coming from negative infinity, but the highest point it gets to on the y-axis is at -4. But your domain will always, for every quadratic that will ever exist, your domain will always be negative infinity to positive infinity. So that's number 2. And 3, let me put 3 and 4 up. Number 3, your vertex was at 0, 1. And number 4, your vertex was at 2, negative 3. Oops, looks like I forgot to do this one. So let me finish it up. Vertex is 2, negative 3. The domain, like I already said, is negative infinity to positive infinity. And your range, since it's going down forever, it's coming from negative infinity. And what's that maximum value it can get to? Negative 3. It does get all the way to it, so we're going to use a bracket, and voila. There it is. Okay? So again, wasn't that hard when we did it. I know it's been a few days, so if you didn't write all this stuff down or do all this before our break, you probably never did it over the break, and then on top of that, you may have forgotten some things. So hopefully you can catch back up on that pretty quickly. We are going to move along today, so at this point, Substitute's going to hand you this factoring refresher note sheet. Factoring refresher note sheet, which really is just a bunch of examples that we're going to utilize in order to explain how to factor. We're going to do 2 different types today. We're going to do set 1, which is just what we call greatest common factor. And that's always the first method of factoring we're going to look to. If we can pull out a greatest common factor, we're going to. And then we're also going to talk about set 2, which is factoring trinomials, where your a value ends up being 1. Now again, I hope you guys remember, when we talk about that a value, we're talking about the x squared coefficient. So when that value is a 1, that's a pretty easy factorable trinomial. So we're going to talk about those 2 types today. And then tomorrow, we'll get into set 3 and set 4. Okay? Set 4 is not that hard either. It's just it's a special type, so we'll discuss that tomorrow. So I'm going to break this first one down really slowly, and it'll be a little obnoxious, but I want to do this to make sure you understand the concept of what pulling out the greatest common factor entails. Okay, so here's what I want you guys to understand. I want you to understand about the number 12. When we talk about the factors, we're talking about the numbers that would actually go into the number 12. So, for example, couldn't I divide 1 into 12? How many times? Well, 12. So 1 and 12 are factors of 12. What else goes into 12? 2 goes in there 6 times. So 2 and 6 are both factors. What else goes into 12? Well, 3 does 4 times. So 3 and 4 are both factors. So my factors of 12 are 1, 2, 3, 4, 6, and 12. Now, let's do the same thing for 18. And we're not going to do this every problem, okay? I'm just trying to make sure you understand what it means to pull out the greatest common factor. Because a lot of times we just pull out the fastest factor that we can find. So, for example, when I see 12 and 18, I'm like, oh, well, 2 goes into it, so I'm going to pull out 2. No, we want to pull out the greatest common factor. So let me explain it using this example, and then we'll go a little faster, obviously, for the rest of them. So 18, what goes into it? Well, 1 goes in there 18 times. 2 goes in there 9 times. 3 goes in there 6 times. 4 won't go in there, 5 won't go in there, and now we're back to 6. So this is it. This is my factors of 18. 1, 2, 3, 6, 9, 18. So when we say what is the greatest common factor, we want to make sure that we're pulling out the number that is the biggest number that goes into both. So as you're looking at this, which one is it clearly? Well, the biggest number that goes into both is the 6. 6 is the greatest common factor. You see, when we are factoring out the greatest common factor, you've got to make sure and do the biggest one that goes into both. So I am going to pull 6 out of both of these terms. Now pause and let me make sure you understand. If you look at both of these terms, see how they can't be combined because one of them has a variable and the other one doesn't? So that's why we have to pull the greatest common factor out of both those terms. So we're going to pull that 6 out. And when I say pull it out, I mean we're literally going to divide it out. So it's like I'm taking 12K and I'm dividing it by 6. So what is 12K divided by 6? Well, that's 2K. So what's left in this first term when I pull the 6 out? 2K is. And we're also going to do that with negative 18. If we divide negative 18 by 6, isn't that negative 3? So we're left inside these parentheses with 2K minus 3. That is how you factor out a greatest common factor. And this is going to be the very, very first method that we are going to utilize every time we look at something where the instructions tell us to factor it or to break it down. We're going to factor out the greatest common factor. Now, sometimes you won't have a greatest common factor, but sometimes you will. So that's what we're going to do in this first set. Okay, so look at number 2. Number 2 has how many terms? It has 2 terms. So we're trying to find, we know we can't combine them because look, one of them has x to the 8th, the other one has x to the 4th. Now I know they both have y's, but because those x to the 8th and x to the 4th are not the same, you cannot combine those 2 terms. So they're separate terms. So I want you guys to think for a second, what is the absolute biggest number that goes into 40 and 64? Again, be careful, don't just say, well, 2 goes into them or 4 goes into them. What's the absolute biggest thing that goes into both? Hopefully, if you've had a little bit of time to think, you see that 8 will go into both of these, 8. So I'm going to factor out an 8. But remember, these have variables. And if you notice, they both have x's, don't they? One of them has how many x's? X to the 8th. The other one has how many x's? X to the 4th. You're allowed to pull out, when it comes to variables, you're allowed to pull out the one that has the least amount. So which one is that? X to the 4th. We can pull out x to the 4th. And then, of course, they both have y, don't they? Just y's. So we're allowed to pull out y as well. So our GCF, our greatest common factor, is 8x to the 4th y. Now, let's pull that out of both terms. Now, I'm just going to go slowly so you can see it. Hopefully, you guys will see it. What is 40 divided by 8? 5. What is x to the 8th divided by x to the 4th? Now, think about this. I had 8. I pulled out 4. How many are left? 4 are left. A lot of times people think you have to divide those. 8 divided by 4 is 2. But you don't treat variables like you treat numbers. See, 40 and 8 are just numbers, so we divided them. But 8, that's an exponent on x, and 4 is an exponent on x. So here's what I say. How many do we pull out of 8? Well, we pull 4 of them out. How many are still left? Well, 4 are still left. And then, of course, the y's will do what? Well, they will cancel. So I'm left with no more y's in that first term. All right, so let's move to the second term. And now we're going to do the same thing. We're just going to use the next term. So I'm going to take 64 and divide it by 8. Well, that's 8. X to the 4th divided by x to the 4th cancels. Y divided by y cancels. So there's no variable remaining in that term. So once I pulled my greatest common factor out, I am left with 5x to the 4th plus 8. So 8x to the 4th y is my greatest common factor. I divided it out, and it left me with 5x to the 4th plus 8. Hopefully that makes sense to you guys. Same thing going on in this next 2 problems. This one is just a trinomial. It's got 1, 2, 3 terms, as you can see. So let's look at just the numbers first. You got 14, 35, and 7. Again, I always like to start with the smallest number right here, 7. The only thing that goes into 7 is 1 and 7, right? Well, will 7 come out of 14? Yep, twice. Will it go into 35? Yes, 5 times. So I can pull out a 7. How about variables, though? How many variables does that first term have? M to the 6th. How many does the second term have? M to the 3rd. How many does the last term have? M to the second. So the least amount is m squared. That's the amount I'm allowed to take out. So let's divide that out of the first term here. Let's divide it out of 14m to the sixth. So here we go. What's 14 divided by 7? 2. What's m to the sixth divided by m squared? Remember, that's like saying, hey, I had 6. I pulled 2 out. How many am I left with? I'm left with 4. So 2m to the fourth. Let's go to the next term. Negative 35m to the third divided by 7m squared. What's negative 35 divided by 7? That's negative 5. And what's m to the third divided by m squared? I had 3. I pulled 2 out. How many am I left with? I'm left with just m. And then lastly, we have this negative 7m squared. So what's negative 7 divided by 7? Well, that's negative 1. And then what happens with m squared divided by m squared? Well, they cancel. So that's why I need that 1 there. So I pulled the greatest common factor, 7m squared, out of all 3 terms, and it left me with 2m to the fourth minus 5m minus 1. Let's move on to number 4, another trinomial. Now, with this one, look at the numbers first. You got 3, 5, and 8. So let's start with that smallest number, 3 here. What's the only thing that goes into 3? Well, 1 and 3, right? Well, will 3 go into 5? Nope. Will it go into 8? Nope. So this one actually doesn't have a numerical greatest common factor. But what about variables? What's that first term have for its a? A to the first, right? A to the first, just a. The second one has a squared. The third one just has a as well. So the most I can pull out of all of them is just a. So let's look at this, the b. The first term has b squared. Second term has b. The third term has b. So the most I can pull out of all 3 is just b. So I can factor out, my greatest common factor is ab. So look at that first term. Well, that's 3ab squared divided by ab. So 3 divided by an understood 1 is just 3. A divided by a will do what? Cancel. B squared divided by b. Okay, you had 2 b's, you took 1 away, you're left with just 1 in return. So 3b. Next term, negative 5a squared b. Well, what's negative 5 divided by an understood 1? Negative 5. What's a squared divided by a? Well, you had 2, you pulled out 1, you're left with 1 more. And then what's b divided by b here? Well, those 2 cancel. So that term is done. Now let's move to the last one, positive 8ab. Well, what's positive 8 divided by 1? Positive 8. What's a divided by a? Cancels. What's b divided by b? Cancels. So we're left with no variables in that term. We just pulled out the greatest common factor, ab, and it left us with 3b minus 5a plus 8. Okay? So that is how you factor out greatest common factors. Greatest common factors, GCF. GCF. We're going to talk about greatest common factor a lot. In fact, when factoring anything, you always need to look for a greatest common factor first. That's got to be your first move, okay? No matter what. When you see a binomial, when you see a trinomial, and I hope you know what I mean by that. A binomial means 2 terms. A trinomial means 3 terms. When you see one of those, the first thing you ask is there something I can pull out of both? So look at number 5. Is there something I can pull out of x squared, 14x, and 45? Well, from a number standpoint, no, because what is this understood to have? It's understood to have a 1, right? So that I can't break that down. And then I can't pull a variable out because look, 45 doesn't have 1. So these do not have a greatest common factor. So we are going to try to learn how to factor a trinomial. Now, I don't know if you guys recall, but let me go over here real quick and show you something. Back when you guys were in Algebra 1, you learned a method, and different teachers call it different things. When you have a binomial times a binomial, A lot of times you guys learned either this little term called FOIL, FOIL, which is just an acronym to tell you to multiply your first terms and your outside terms, your inside terms, your last terms. Some of you guys may have learned this and called it double distributive. Double distributive. Either way, I don't really care which one you call it. When I work this problem, I first have to take my first term here, x, and distribute it to this x. So x times x is x squared. Then I take it and I distribute it to this negative 5. So x times negative 5 is negative 5x. See, I've distributed x to everything on the right side. So now I move to the 3, and I do 3 times x. Well, that's positive 3x. And then positive 3 times negative 5 is negative 15. If you notice, we have some like terms here. They both have an x. So I'm going to bring the x squared down. Negative 5x plus 3x is negative 2x. And then the minus 15 drops down. So when we multiplied a binomial, 2 terms, times a binomial, another 2 terms, it gave us a trinomial, x squared minus 2x minus 15 in return. Now, what we're doing today, what we're learning today, is we're learning how to go in the opposite direction. How can I take this trinomial and break it back down into 2 binomials? That's what we're talking about today, factoring a trinomial. So it's kind of like, if you notice here, didn't the first term here times the first term here give us this term? And that term made it the whole way, didn't it? And then didn't this last term here and this last term here give us this value? And it made it the whole way. That's exactly where our focus is going to be today when we do this. But the key is, whatever those numbers are, they have to give me the value that's in the middle. So that's where you have the ability to find what your 2 factors are that would have in turn given me x squared plus 14x plus 45. Okay? So first of all, remember, we're focused right here. What would have multiplied to give me x squared? Well, that's x times x. So we know with absolute certain that these 2 spots right here have to be x times x. You understand? I hope so. Now, the next thing, this is where it gets a little more tricky. These 2 values here and here have to give me 45. But if you think about that, can't 1 times 45 give me 45? Can't 3 times 15 give me 45? And can't 5 times 9 give me 45? So that's 3 different things that could potentially have given me that value of positive 45. So let me explain how we can determine which one it is. And I know that some of you guys already see this. The first thing that I want you to recognize that's really important is the sign. Right here. Do you notice how that sign is positive? What 2 things can multiply to get a positive? Well, a positive times a positive can give me a positive. And can't also a negative times a negative give me a positive? Both of these are my possibilities here. The other possibility is if something is positive and the other is negative. And it doesn't matter where you put them, it still would make your solution negative. So it has to be this one in this case. But how do I know if it's 2 positives or 2 negatives? Well, that's where this middle term comes into play. What's that value right there? Well, it's positive. Well, then without a doubt, this has to be positive, positive. Okay, so that takes care of the first thing. We know with absolute certainty that this right here is going to be a positive and a positive. So how do I know whether it's 1 and 45, 3 and 15, or 5 and 9? Well, it's all about that middle value. When they're both positive, what would happen with 1 and 45? What would that give me? It'd give me 46. That's not 14. What about 3 and 15? Well, that would give me 18. That's not 14. What would 5 and 9 give me? Bingo. There it is. It has to be 5 and 9. 5 and 9 are the only 2 factors that when I put them right here, Not only do they multiply to get 45, they combine to get positive 14. So x squared plus 14x plus 45 factors down into the two binomials x plus 5 times x plus 9. That is how you factor a trinomial. Okay? Was that tricky? I hope not. Let's keep on cruising over here. Again, don't forget, we're always going to look to see if there's a GCF. Can I pull something out of w squared, 15w, and 26? Well, no, because look, that's just a 1. Can't pull that out. This doesn't have a variable. Can't pull anything out there. So this is ready to factor into two binomials. So let's get it started. What times what will give me w squared? W times w. And what are the things that will multiply to get 26? Well, it's 1 times 26. It's 2 times 13. 3 won't go in there. 4 won't go in there. 5 won't go in there. 6, 7, 8, 9, 10, 11. Nothing goes in there. This is it. We don't have a ton of choices here. All right, so here's what we're going to do next. We're going to look at the sign. What's this sign right here? Well, it's positive, right? That means that they're either both positive or they're both negative. So I look here at this middle term, and what does it tell me? They're both negative. They're both negative. So I know without a doubt that this right here has to be minus, minus. So they're combining, okay? They're working together. They're working together to get that middle term. What is that middle term? Negative 15. Well, if I put negative 1 and negative 26 together, wouldn't that give me negative 27? But what about negative 2 and negative 13? What would that give me? It would give me negative 15. So boom, w minus 2 times w minus 13. That is my factors for w squared minus 15w plus 26. I hope that makes sense, because a lot of times people really struggle with this section, okay? We're going to keep on going. This one's going to be a little different, so let's take a look. Right here, that's a 1. You can't pull a 1 out of everything. This doesn't have a variable, so you can't pull a variable out of everything. So this thing is ready to factor into two binomials. So let's start right here. What will multiply by itself to get c squared? Well, c times c. Now let's think of some factors of 48. There's a bunch, okay? So 1 times 48. If you want to find these factors, just go to your calculator and start dividing 48 by different numbers. Go 48 divided by 1, 48. 48 divided by 2, 24. 48 divided by 3, 16. 48 divided by 4, 12. 48 divided by 5 doesn't give me an even number. 48 divided by 6 is 8. 48 divided by 7 doesn't work. So then we're back to 8 and we're cycling back through. See, so I don't have to keep going because it would just cycle back through. So here are all my different factors of 48. Now I want you to notice something though. What sign is that? See, this time it's a negative. So that means one of these has to be a positive and one has to be a negative. And it absolutely does not matter right now where you put them. So I'm just going to put plus in the first spot and I'm going to put minus in the second spot. Now here's how this works differently when those signs are opposite each other. You see, they're not working together anymore. They're working against each other. So when I look at this right here, what's the gap between 1 and 48? Well, that's 47, not 2. What's the gap between 2 and 24? Well, that's 22, not 2. What's the gap between 3 and 16? Well, that's 13, not 2. What's the gap between 4 and 12? Well, that's 8, not 2. What's the gap between 6 and 8? There it is, 2. It has to be 6 and 8. Now be careful. How do I know where I put the 6 and where I put the 8? It does matter. So here's how I know. What sign dominated when these two faced off? Positive 2, 1. Positive 1. So positive has to go with my bigger factor. Which one's bigger, 6 or 8? Well, sure, 8 is. So 8 has to go with the plus, and 6 has to go with the minus. And that's how you do them when the signs are opposite. So the two factors of c squared plus 2c minus 48 is c plus 8 times c minus 6. I hope that makes sense, because that's about all the different methods of factoring. Really, it's you either have them both positives or they're both negatives, or one's positive, one's negative. So we've already kind of dealt with all of them. So let's just look at a couple more examples, and then I think you guys should be good to go. So here we go. We've got n squared minus n minus 72. I definitely can't pull out a greatest common factor because n squared just has a 1 and 72 does not have a variable. So here we go. We're going to write our two binomials, and we're going to start with the easy. What multiplies by itself to get n squared? Well, that's n times n. And I'm going to think through some of my factors of 72. 1 times 72, 2 times 36. It's bad. I'm needing my calculator. I haven't done math in a while too. 72 divided by 3 is 24. Let's see, 72 divided by 4 is 18. 5 definitely doesn't go into it. 72 is divisible by 6 12 times. 72 divided by 8 9 times. And I think that's it. Definitely it. It obviously cycles back through now at this point. So there they are. Again, those are all of my possible factors, but it can't be just any of them. It's got to be one of the sets. So what I do is I look at the sign. It's a minus, right? So that means one of these has to be positive and one of them has to be a minus, and it means they're working against each other, okay? They're fighting, basically. So we're looking for a gap of, well, what's this value right here in the middle? A gap of -1. So a gap of 1. So we can kind of cipher through these pretty quickly. Does 1 and 72 have a gap of 1? No. 2 and 36? No. 3 and 24? No. 4 and 18? No. 6 and 12? No. There it is. It's at the bottom. 8 and 9. 8 and 9 have a gap of 1. So once again, we just say, hey, what sign wins in the middle when these two paddle? Negative wins. Look, it's minus n. Negative wins. So it has to go with the bigger factor, and that is 9. 9 has to go with the minus because it won, and 8 has to go with the plus because it did not win. So the two factors of n squared minus n minus 72 would be n plus 8 times n minus 9. Okay? Now you're always welcome to go back and multiply those in to see if it would give you those trinomials, and I guarantee you they would. Let's go down here to number 11, because in number 11 and 12, you have a GCF, okay? Don't forget to always check to see if there is a greatest common factor. If you notice, in all three of those terms, what can they all be divided by? A 2. So if there is a greatest common factor, pull it out. So here we go. What is 2k squared? 2k squared divided by 2. What's k squared? What is negative 16k divided by 2? Well, negative 16 divided by 2 is negative 8, and then the k drops down. And then finally, what's negative 40 divided by 2? Negative 20. Now, what I want you to do, and don't mark this out, okay, but ignore it, and let's just write it down, and let's factor just the trinomial, okay? Ignore the 2, write it down, and let's just factor the trinomial. Once again, what will multiply by itself to get k squared? K times k. What are some factors that give me 20? Well, that's 1 and 20, 2 and 10, 3 won't go in there, 4 goes in there 5 times, and now we've cycled back. Here are my different possibilities. Now again, remember, look at the sign. That's a minus. That means one of these have to be plus, and one of them have to be minus. So they're working against each other, and they're working against each other to give me what value? That negative 8. So let's see. Which one of these to the right have a gap of 8? Does 1 and 20 have a gap of 8? No. 2 and 10 have a gap of 8, don't they? 4 and 5 just have a gap of 1. So it has to be 2 and 10. Last thing, what sign dominated the middle? Minus did. Minus wins. So minus has to go with your bigger term, which is the 10. So k minus 10, k plus 2. So my total factored answer to this problem is 2 times k plus 2 times k minus 10. That's how you do number 11. And last one, let's scoot over here and do number 12. Once again, notice the greatest common factor. They're all divisible by 5. So let's do that. What's 5z squared divided by 5? Z squared. What's negative 25z divided by 5? Negative 5z. And finally, what's positive 30 divided by 5? Positive 6. So I'm going to drop the 5 down, and we're going to factor this into two binomials. Ready? Let me use a different highlighted color. So what multiplies by itself to get z squared? Z times z. What are some things that multiply to get 6? Well, that's 1 times 6 and 2 times 3, and that's it. Now look, what's the sign here? Plus. That means that they're either both positive or they're both negative. So I look at that middle term, what is it? They're both negative. So that tells me they're combining, right guys? They're combining. They're combining to get 5. Whoops, I meant to highlight that, not mark it out. So which of these sets combine to get 5? Well, these combine to get 7. I know they have a gap of 5, but remember, those signs are both negative. So it's not about the difference between it, it's about combining. So it's not 1 and 6, it has to be 2 and 3. 2 and 3 to combine to get 5. So there it is. It's 2 and 3. So my total factored solution is 5 times z minus 2 times z minus 3. And that is how you factor greatest common factors, and it's how you factor trinomials when your a value is just 1. Tomorrow, we'll talk about how to factor trinomials when your a value is not just 1. Okay? It'll be a little harder, but it's not something that we can't handle. It just makes the process of breaking it down a little bit more complex. And then the set 4 that we're going to do, those difference of squares, that's a joke. That's easy. You won't have any problems with that. So your homework tonight is the factoring refresher day 1 worksheet that your substitute Ms. Stevens is about to hand out to you now. And your homework is numbers 1 through 14. 1 through 14. You shouldn't have any problems finishing those up. Okay? Hopefully you won't. I will be back tomorrow, so we'll definitely be able to help you out with this. If you have any questions, we'll deal with that tomorrow. All right, I'm going to shut this off. Thank you guys for paying attention, and we'll see you tomorrow.